I'll introduce myself first. So yeah, my name's Ian Forsyth. I work for 2G Energy. I've been working there for 9 years. So background is, well, I'm a chartered mechanical engineer still. Worked in defence industry at BAE Systems for 20 years, and I've worked in CHP for the last, or CHP and district energy, actually district heating for the last 15 years. So that's my background. So I'm in sales at the moment, but yeah, covered all areas of working in this area. So yeah, so I've got basically it's a presentation on hydrogen applications in CPD. So it's a little bit about hydrogen itself, probably how we use the gas in our engines, and then some case studies as well. So that's pretty. I've only got one slide on the company, just so you got some context as to who 2G are. So they're a German company, founded nearly 30 years ago. So we're actually a manufacturer of engines. We're not just a packager. So hello, all right.
Johnson.
All right, I'm Ian. So nice to meet you. All right.
We've still got one or two more people.
Oh, still coming.
So, yes.
Okay.
I'll be back in a moment.
Okay, correct. Yeah, so we're actually a manufacturer of engines, and then we've got we've also got a number of subsidiaries, and the UK is one subsidiary. So we're based in Runcorn, which is only like 20 minutes away from here. So there's about 60 odd of us in sales, project management, and service of gas engines. So we only make gas engines. So they could be biogas, natural gas, or hydrogen, or syngas, or could be landfill gas, any type of gas. And we do a massive range. Yeah, quite a big company now. So actually the third biggest CHP manufacturer in Europe. So I think we just keep growing, and we've sold over 9,000 engines globally. So that's the company. Trying to move this out of the way. Right, so this is just to put hydrogen in context, I suppose. So traditionally, CHPs, most CHPs in the UK, combined heat and power, that is. So that's a gas engine that produces power and heat simultaneously, I guess. You've got building or industrial applications. You've also got solar and wind. That's pretty common. It has been for the last sort of 10, 20 or so years for producing power. But in terms of other uses of that power and how that integrates with CHP is growing quite a bit. So one of the main technologies to producing hydrogen, and there's obviously many ways to produce it or obtain it, is electrolyzer technology. So using ideally, you've probably heard of different types of hydrogen, different grades: green, blue, yellow, all sorts of different ones, depending on what the source of that, how the hydrogen's made. So ideally you want green hydrogen, which is from, renewable sources. So that's solar and wind. So you need an electrolyzer to be able to break down water into hydrogen and oxygen, and then you can store that hydrogen, because quite often, well, actually, I think the way it's going to work is, especially with wind, developers are paid to turn wind turbines down at night, I believe. So why not use that spare power to produce more energy and store it in the form of hydrogen? So that's kind of one of the main ideas. And then that hydrogen can either be used directly in an engine. Hello. Hi. Which I'll come on to more in a minute. Either as a percentage, or blended with natural gas. Hydrogen can be injected into the grid. You've got other forms of gas being injected in the grid. Biomethane is quite a big thing at the moment, and it's one of the few technologies where there's actually incentive to do that. So there's a lot of biomethane plants being developed at the moment, and so we can either take grid gas, or we can take hydrogen, as directly as 100%, or we can take a blend of both. So that's really all that's trying to show. So, oops. Okay, so in a gas engine, traditionally, most gas engines are turbocharged. So so you mix in the air and the gas together. You're compressing it. You're then turbocharging it, and that's how you get high efficiency gas engines. But you can't put hydrogen. You can't put more than a certain percentage of hydrogen through a turbocharger, because it'll blow up, which I'll explain in a minute. So you can only put up to 40% hydrogen in. So that's a traditional way most gas engines operate. Same with the car. Exactly the same with the car. No different. Oh yeah. How did you want to do the food? I'll let you have. I've got all sorts, so just put it all out. So just in terms of hydrogen itself and natural gas. So hydrogen, well, natural gas is typically well, it's got a it's classed in terms of methane number, or that's a good way of categorizing gases. And methane is the resistance is described as the resistance to detonation of a particular gas. So actually, methane is given a number of 100 in terms of methane. In terms of methane, hydrogen is given a value of 0. So in other words, hydrogen is highly susceptible to detonation, and natural methane isn't. It's a different sort of reaction. So you're not detonating. So that's one of the issues with hydrogen. It's highly reactive. So and then we have that one in the middle. Really, that will be probably biogas. So that's got a higher methane, because that's even less susceptible to detonation. So that's really all that's shown there. And yeah, so and this is the same as when you're burning petrol or whatever. You've got quite a narrow range of lambda, which is the fuel air ratio in terms of operation. So most cars now work at sort of like lean burn, and it's the same with gas engines. They all work in the same way, but so the range is quite narrow. But with hydrogen, you've got a much wider ignition range, in which you can work at a much higher lambda level. That's because I think it's because hydrogen is more susceptible to being to reaction. So yeah, similar ignition temperatures, but the fact is it's more able to react. And then if we go on to the next slide, which is, oops, yeah. So this shows you how with a gas engine we operate in a much low on the sort of on this curve here. For natural gas, you were operating around here, so quite a lean burn sort of operation, whereas with hydrogen we're operating out here, which means the emissions are much lower. So you can and there's no CO2 emissions so much. So does that make sense?
So the hydrogen is lower
in terms of NOx emissions. NOx emissions are much lower typically. So in other words, you don't need sort of that complicated catalytic converter technology to be able to achieve low emissions with hydrogen, and you've got a zero CO2. Okay, so this is quite interesting. So this really is just summarising the fact that hydrogen has it's got 3 times less. It might be more susceptible to detonation, but it's got 3 times less energy per volume than natural gas. you need a lot more hydrogen. So it's something to be considered. By mass, it's got a higher energy content, but by volume, which is how it's going to, how it's delivered, I guess, then it's a lot lower. And we need pressure of about 4 to 5 bar, which I'll explain how we do it in a few minutes. So whereas natural gas, it operates at much lower, it could be as low as 20 millibar for gas into our engines, which is typically aligns with the low pressure mains. Okay, so as explained with a conventional natural gas CHP combined heat and power engine, we have to go through a turbocharger to get the maximum efficiency of an engine. Can't do that with hydrogen, so we still compress the air, but we only add the hydrogen as it's going into the cylinder. So that's the only real difference. So the engine itself is exactly the same. And we just have an additional gas injection valve here before it goes into the cylinder to be mixed with the air, and that's the only difference. So we just have this little gas injector on the fuel line. Okay, just another view of it. So to keep moving that around. So we can either have 100% natural gas, or we can have 100% hydrogen, or we can mix any volume in between. So it's just showing we've actually neatened all this up now. We're still in development mode, even though we've got engines out in the field operating the hydrogen. We're still trying to improve the way in which we deliver the hydrogen into an existing engine. But the bottom line is the existing engine doesn't change at all. It's still exactly the same. So just a 6-cylinder engine. So we have a whole range of engines that can operate on 100% hydrogen, and they still have quite good electrical efficiencies, similar to what you would get in a natural gas engine. There's another one here at the moment, but so actually so the biggest one is in natural gas, that would be a 1 megawatt engine. At the moment, we're derating our engines only because we're still kind of, even though we've got products that are commercially viable and operational, we're still developing the technology and our engines, and we're trying to be conservative. So because our factory is going to have a hydrogen gas line in Germany running past it, and we're going to be, once we've got that, we'll be able to do a lot more lot more run hours, in-service run hours on engines. And then the aim is to get the hydrogen engines to the same output as a natural gas engine. But at the moment, they are derated by typically about 25%. So that's normally a 1 megawatt natural gas engine. At the moment, it's 750 kilowatts. So, and the same for all these would be that would normally be 360 kilowatts. So yeah, this just summarizes that really. So hydrogen efficiencies for different engine outputs, not too dissimilar to a natural gas engine. So from an efficiency point of view, it's still pretty good. Thermal output, not too dissimilar, maybe slightly lower, but still pretty good. So you just need, at the moment, you need a slightly bigger gas engine to run a hydrogen for the same output than you would with natural gas. So that's just one consideration. Okay, that's just quite interesting. So when you mix in, when you mix in hydrogen with natural gas, for example, then for if you for 20% hydrogen. Hang on, let me get this right. Yeah, sorry. 20% hydrogen, you're getting about, I think it's about 7 or 8% CO2 reduction. Not straight line, that's one thing. So 100% hydrogen, you're getting 100% CO2 reduction. So even 20% is good, and that's what I believe they're planning to inject into the grid, to the national grid, you're probably aware of. So these are just some case studies now of hydrogen engines we've got operational globally. So there is only one in the UK that's operational. That's at Kirkwall Airport in Orkney, which you may or may not be aware of. I'll come on to that anyway in a minute. But we've actually sold 30, I think it's around 30 hydrogen engines globally to run on 100% hydrogen. And the first one in the world was at Berlin Airport, which the Germans are not particularly proud of because it had various issues with the airport, and I'm not even sure it's fully operational now, to be honest. But it's kind of like a bit like I've shown you before. It's a bit like an integrated solution. So you've got wind providing power for the electrolyzers, which is then producing hydrogen for. So it's either you're storing the hydrogen. Oh, that's heat. Storing the hydrogen. Hydrogen can be used in a gas engine. Hydrogen could be injected into the grid. Hydrogen could be used in fuel transport. This is an electric charging system. So there's obviously got the wind and the solar there providing power for electric car charging. So there's many different ways. It's a whole integrated solution, and most of the case studies I've got are all very similar, to be honest. One thing you do need, as I mentioned before, is hydrogen storage. So you do need to be able to store the hydrogen on site, because likelihood is it's not always going to be produced, necessarily when it's needed. But yeah, that was the first one, and that was about 2012. And it was really a research project at the time. So this is just showing similar. So that's just the gas engine. It's a 6-cylinder engine. Only showing you what I was showing you earlier. This was quite an interesting project in Dubai. So for the Dubai Expo, this was in conjunction with Siemens. So it's part of a large solar farm. In fact, I think the next slide shows that. I'm not sure all the slide is on this in this view or not, but it might not. Yeah, so solar providing the power for the electrolyzer, you're storing it, and then that goes into the CHP, which as I understand, it's powering an absorption chiller as well. And the hydrogen is being injected into the grid as part of a low carbon local power network. So
is that actually tri-jet generation?
Well, it is, isn't it? Yes. Well, actually, because normally you'd be using the heat. In the UK, you'd be using the heat for heating buildings, but I guess over there they're probably not, are they?
No.
It's probably just using it probably isn't in this instance. It's probably, normally if you've got an absorption chiller, you're using the low grade heat for heating or hot water, and then you've got absorption chilling, which that's what you call trigen, with the power generation as well. Yeah. This is another one in Germany. So there's a couple of case studies in Germany, Hasfert, which similar to what I've shown you before. So you got wind providing the power for the electrolyzer, which powers the CHP. So that's just 10% volume by volume. So our gas engine can take up to 40% volume of hydrogen before you need to do the full conversion to add the direct injection system on. So you can still go through a turbocharger with our engines up to 40%. Other suppliers say a different number. Some will say 10, some will say 25. Everybody has a different number. I'll put 100% hydrogen through a normal gas engine. And then storage and the CHP can work on 100% hydrogen or a blend of hydrogen. yeah, and this is that's the electrolyser. That's the CHP, containerised CHP. This is another one. This is the part of a district, well, sort of typical mixed use scheme, I guess, probably typical to what you guys sort of come across quite regularly. So this is part student accommodation, part shops, apartments, office blocks, etc. Again, this is in Germany. So again, it's very similar. So you've got green electricity providing the power for the electrolyser, which is then storing the hydrogen, which is either going into the gas grid or going directly into the CHP, or both. CHP produces power. So yeah, yellow is power, red is heat, so heating the residential buildings and the university. And it looks like there's also some electric charging. So I think all these projects, they've all got, you know, a holistic sort of approach to energy supply and utilization. There's not one technology that you can just use. So this is using heat pumps as well. In fact, we've got a project in Birmingham at the moment. It was through CHPs, so with the consultants on it, and that's a CHP and heat pump solution as part of a wider district scheme. So we supplied an engine there earlier this year. So that is one way in which I know CHPs can work with other technologies. This is Kirkwell Airport. Again, this was really a demonstration project funded by the European Marine Energy Centre. When you saw that energy programme, I think it was Channel 4 with Guy Martin about a year ago, and this did feature on that programme because he was looking at all kinds of different energy solutions, nuclear and whatever, but it did cover hydrogen, and it did go there. So yeah, the hydro. This is all part of the wind turbine, not to wind turbine. So the tidal turbine system that they've got there. So instead of wind producing the green electricity for the electrolyser, they're using tidal turbine. The only thing is where the turbine is and where the hydrogen is stored is not where the CHP is, because it's on a different island. So they have to bottle the hydrogen and then bring it. Yeah. But the technology works, so it's a demonstration project. So you may or may not be interested in maintenance, because some people ask, well, isn't it more complicated or expensive to maintain hydrogen engines? And it's not really, because the engine technology is no different. All you've got is an additional injection system, and I think there's another filter that we have installed as well. So really, there's not really much additional cost in terms of maintaining the hydrogen engine to a normal natural gas engine. And you might have an additional heat detector, I think, in a container, because we have gas detector. Xtox, by the way, is our gas detection system. So that's just standard. So it's all fairly standard. There's nothing scary about maintaining a hydrogen engine specifically. This is just, I'll get the head around this. This is just showing how, with a normal natural gas engine, you're wanting to use as much of the heat as possible to get the best return on investment. So if you've got no heat utilization, I mean, every application is different, but and it all depends on the size of the CHP and etc. But this is just a typical example. So by using all the heat, and obviously you can significantly reduce the return on investment. And also, so with hydrogen, it's all down to the hydrogen price. I actually don't know what it is at the moment. You might have a better idea than me, but it was 12, 14p about a year or so ago. In fact, natural gas wasn't far off that about a year ago, was it? I think we're paying 10p at one point. In fact, I'm still paying about 7p at home. You guys are paying. But so once hydrogen comes down in price, then the return on investment is going to come down. And once we can get hydrogen to the same price as natural gas, with or without incentives, probably will need incentives, then we've got, I think that's why it's done the slides in conjunction with a typical natural gas application. We've got a viable project, which is where we need to get to. So with high with high hydrogen price, then projects are just not viable. So that's why nobody's really doing hydrogen CHPs at the moment, as well as the logistical aspect of where's the hydrogen coming from. That's what we have. That's what happens when we do exhibitions, which are going to the All Energy one in a week or so, by the way. And people always ask, "Oh, this technology is great, but where do I get my hydrogen from?" So that's always the question. So, and that question is still valid. So it's either going to be injected in the grid, maybe up to 10%. That was supposed to be happening last year, but it still hasn't been approved, I don't think. Or it's going to be more local production of hydrogen through electrolyzer technology, or bottled in and supplied in. But then you need somewhere to store it. So there are some logistical issues to consider regarding hydrogen, especially if you're wanting to go, 100% hydrogen.
And that return on investment is if you're just getting the hydrogen from somebody. It's not with an electrolyzer.
No, well, that's it.
That's expensive thing.
Well, they're about, for a 1 megawatt electrolyzer, they're over £1 million. So they're quite expensive. So, it may be that electrolyzer technology disappears entirely because they have found natural sources of hydrogen, which you may know about. So it's called. Well, I'm not sure about the UK. They probably have, but I think definitely in Australia, in Italy, France. It's called gold. Check out gold hydrogen. Google gold hydrogen, because there's natural sources of hydrogen which could be a game changer, because if they can mine that, just like they can natural gas, and it's carbon free, everybody's happy, aren't they? So, and they can do it at a competitive price. So there's a lot of people working on that at the moment. So in terms of exploration. So I've only got one other slide really, which is conclusions. So our own 2G engines can run on up to 40% hydrogen without any conversion. If you want to go above that value, then you've got to have an additional gas injection system, which can be retrofitted, or you can buy at the same time as a CHP. Doesn't matter. I'll just have that there. So, and the other thing about hydrogen engines, reciprocating engines, is we don't need pure hydrogen. So with fuel cell technology, you need pure hydrogen. So we can take hydrogen from many different sources. So it could be an industrial hydrogen, which is more grey hydrogen, or electrolyzer hydrogen, which would normally be green hydrogen. And we can blend hydrogen with other gases, natural gas, could be biogas, but I've not seen many applications of that yet. So quite flexible in terms of how we can use that hydrogen. Any hydrogen, I guess, will give you some carbon savings. So if that's the most important thing, then hydrogen is a good fuel to use in gas engines. So we can retrofit when the conditions are right. So so zero carbon emissions, and as I mentioned early on, so low NOx emissions as well. So typically, that would be well within the medium combustion plant directive for emissions, NOx emissions, and normally within what most city centres are able to are specifying. So so basically what we try and say is, what for customers, where are you on the journey? Do you want to be carbon zero now, or do you want to be carbon zero in 10 years or whatever time? Because you can buy a natural gas engine now, so it's ready to convert to run on hydrogen or a percentage of hydrogen in the future when hydrogen is more available. That's kind of the message we're saying, because obviously hydrogen's not readily available yet. So it's just trying to make sure customers buy technology that's not it's not old technology. I've forgotten the word I was thinking of using. Redundant. Yeah, there's another word, but redundant will do nicely, thanks. Stranded asset, basically. You don't want to be buying a stranded asset. A lot of gas engines are still specified as 80 methane engines, which is actually struggling which means they're even struggling with the natural gas in the UK at the moment, which obviously varies throughout the UK. It's historically it's always been above 80, but now it is generally less than 80. So unless you've got a 70 methane engine now, we've changed our what we offer now. All our engines are now offered at 70 methane engines. It's only the sort of like cheaper imported engines who are still trying to sell 80 methane engines because they've not had the development on them to be able to operate at low methane numbers. So if you see an engine specified at 80 methane, I'd sort of like, red flag alarm bells, because that's probably not going to be, not only not going to be good enough for natural gas in the future, because natural gas is going to be made up from different sources, as I mentioned. It's going to be biomethane injection, but it won't be good enough for for even a percentage of hydrogen when that gets injected into the grid. So just be wary when you see a natural gas specification, what the methane is, whether operating on natural gas or what a client might need in the future. So really, that's it. So presentation finished. Can answer any questions. Got some. You can have a hydrogen pen. It says, look, hydrogen ready pen. I'll give you some pens. I've also got. See, guys online can't see this, but I've got a brochure which I can send. I can send this out electronically. Probably can't see that, but it's a short brochure which covers a bit more about the technology and some of the case studies. I can send you the presentation and give everybody a CPD certificate if I just know the names. So I can do all that. I can leave these here, and yeah, that's it really. If anybody's got any questions, more than happy to answer them.